Some trig word problems that we use are when we talk about something called an angle of elevation and an angle of depression. An angle of elevation is the angle formed by a horizontal line and a line of sight to a point above the line. In this diagram down here, angle 1 is your angle of elevation. Okay, it's as we look up, angle of elevation. Angle 2 is an angle of depression. That's the horizontal line and a line of sight to a point below the line. The thing that you need to understand is because these lines are parallel, because horizontal lines are parallel, angle 1 is going to be congruent to angle 2 because they're alternate interior angles. Because these are parallel, the horizontal lines. So that means alternate interior angles. So the angle of depression, angle of elevation are really the same measurement. And so if you get confused with which one is which, and you've been given one of the angles, it's okay, you just use the other angle. You just use it as an angle of elevation or depression. So the first question says, classify as angle of elevation or angle of depression. And so when we look at this, we can see angle 1 is an angle of depression because it's formed by the horizontal line and a line of sight below that line. And angle 4, we're looking up. So that's your angle of elevation. Okay, because we're looking to a point above that line. For the next problem, the next picture, we're looking at 3, 4, 5, and 6 right here. And it says, what is the angle 5? So angle 5 is looking down, because here is my shape, so that's an angle of depression. And angle 6 is looking up, angle of elevation. Okay, so that's just labeling them at this point. So now let's do some word problems with them. The Seattle Space Needle cast a 67-meter shadow, depending on where the sun is, obviously. If the angle of elevation from the tip of the shadow to the top of the Space Needle is 70 degrees, how tall is the Space Needle? So this is how tall it is right here. This is its shadow right here. And here's my angle of elevation, 70 degrees. Now, we know we have adjacent and opposite. So we've been given adjacent and opposite, so we're going to use tangent. Remember that, what do we know or what are we given? And we've been given the adjacent and opposite. And an angle. Sorry, we're not given the opposite. We're given the angle. And we want the side opposite the angle. And when we have opposite and adjacent, we can use tangent. So the tangent of 70 degrees is y over 67. Multiply by 67 to get 67 times the tangent of 70. And I'm going to, on my calculator, 67 times the tangent of 70. Make sure you're in degrees. We get 184.08. And round to the nearest meter, 184 meters. Okay, so that's that first example. Let's look at this next one. An ice climber stands at the edge of a crevasse that stands 115 feet wide. So 115 feet wide right here. The angle of depression from the edge where she stands to the bottom of the opposite side is 52 degrees. So this is 52, this is 90. That makes this 52. It makes this whole thing up here 90. So technically, we don't need to find that angle, but it is 38 because remember the acute angles are going to add up to 90 because it's a right triangle. The question is how deep is this? So we're looking for this here. So what we know or what we are given is an angle. We're given the adjacent side And what we want is the opposite side. And so again, we're going to use tangent because opposite and adjacent is tangent. So the tangent of 52 degrees is y over 115. 115 times the tangent of 52 equals y. So y is 115 times the tangent of 52. 115 times the tangent of 52. 147.2. We're going to round to the nearest foot, so 147 feet. Now you could find that third side by using Pythagorean theorem if you wanted to, but we're not going to at this point. I could say, well, you know, how far if I went diagonally, but I don't need to. So that's the first two examples with this. We've got a forest ranger up in a tower, and he sees a fire from a tower, not a towel, oops, a tower, sorry, that is 90 feet tall, and the angle of depression to the fire is only 3 degrees. So that angle of depression is right here, which means it's going to be right here. It's only 3 degrees, so that's probably pretty far away. What is the horizontal distance? Again, no or given is an angle and the side opposite. We want the adjacent side, so we're going to use opposite and adjacent, which is tangent. So I'm going to say the tangent of 3 degrees, remember it's always tangent of an angle, is 90 over x. Now remember this one algebraically, because we're going to be solving for x. If we multiply both sides by x, we have x times the tan of 3 is 90, which means x is 90 divided by the tangent of 3. So really we're just flipping or switching places. So x is 90 divided by the tangent of 3. And I like to use parentheses when I do this. I'm going to go 90 divide, and I'm going to put parentheses, tangent of 3, and I get 1,717 to the nearest foot, and it's 0.3, so I'm going to round to 1,717. 0.3 or just feet. So you can see, like I said, it's a long ways away. Again, we could find the hypotenuse. Let's pretend that the question is if he takes a zip line, how far is it on the zip line? We could use that. We could find the hypotenuse by taking 1717 squared plus 90 squared equals hypotenuse squared. So the hypotenuse is going to be the square root of 1717 squared plus 90 squared, and square root of 1717 squared plus 90 squared is 1719.4, and that's going to be that hypotenuse. Because it's 3 degrees, it's not going to be very much of a difference because it's only 3 degrees. And when you have angles that are that small, the side is going to be very close to the hypotenuse because 3 is really tiny. All right, a tree casts a 12-foot shadow, a 15-foot tall tree. So the tree is 15 feet. And I'm going to make it like this, and I'm going to say that's 15 feet. And the sun is shining like this, and the shadow is 12 feet. What is the angle of elevation to the sun? So we're going to look for that angle right there. So we have opposite and adjacent. We want the angle. We're going to use tangent. We don't always use tangent with angles of elevation and depression, but a lot of times, probably 80% of the time, we do use tangent, simply because we're finding angles, or we're finding shadows and all of that. So, yeah. So the tangent of the angle, we're going to use that theta. I'm going to use theta right there. It just stands for an unknown angle, is 15 over 12. Because we're looking for an angle, we're going to use inverse So we're going to say the inverse tangent of 15 over 12 is going to give me theta. And so I'm going to take inverse tan, second tan, 15 divide 12, and I'm going to get 51.3. I'm rounding to 51 degrees, and that's going to be my angle of elevation. Okay. Last problem. It's about a building and a ladder. You see these a lot. You'll see a lot of problems like this. We have a ladder that's 12 feet long, and it's leaning against a building. And the angle of elevation is 32 degrees. How far up the building does the ladder reach? And it says draw a picture. Here's my picture. Here's my building. And there's my ladder. All right. Not good at art unless you practice. And I'm not going to practice my art. So we know the hypotenuse. And we know an angle. We want the side opposite the angle. Because we have opposite and hypotenuse, we're going to use sine. Because again, the sine of an angle is opposite over the hypotenuse. Okay, so sine of 32 degrees is x over 12. So 12 times the sine of 32 equals x. And again, we multiply because it's in that denominator. It's like saying 3 equals x over 12. What divided by 12 is 3? Well, 36 divided by 12 is 3, and that's why we multiply. 12 times the sine of 32 is 6.4. And I'm going to say 6.4 because I did not say to round. And so I'm going to say it reaches about 6.4 feet. Now remember, if I say 6.4 feet, I'm not saying 6 feet 4 inches because it's base 12, which is a foot. And so I'm taking that 4.4 times 12, which is 4.8 inches. So it's 6 feet 4.8 inches if I round. And that is angle of elevation and depression. Until next time.